Hello everyone, I'm Dharani here. In this video, we're going to deal with the multi-layer perceptron and its implementation on any non-linearly separable data. Without any further delay, let's get into the video. In this video, we're going to see what an MLP, that is multi-layer perceptron, is, implementation of MLP for a non-linearly separable data using Python, execution and results of the program, and the various applications of MLP. Before knowing about MLP, let us have a small idea about the linearly separable and the non-linearly separable data. Linearly separable data refers to a dataset in which two classes of data points can be separated by a linear decision boundary. As we can see in image A, the class blue and class red can be separated using a single straight line. Whereas when we come to non-linearly separable data, which we are using in our experiment, there can be no straight line to completely separate the classes. Instead, they need a complex or more sophisticated decision boundary to separate them more accurately. Now let us see what an MLP is. A multi-layer perceptron neural network belongs to the feed-forward neural network in which all the nodes are interconnected with the nodes of different layers. Basically, it works only in the forward direction. The network consists of three main layers, such as the input layer, hidden layer, and the output layer. Now let us move on to the experiment. The main objectives of the experiment include implementing a multi-layer perceptron. That is, the program implements a basic MLP model with one hidden layer to solve the classification problem. The next step is to train the MLP using backpropagation. During the training, it updates the weights of the network to minimize the loss function. Next is to visualize the training process. It plots the loss value over training epochs to visualize how the loss changes during the training. Next is to make predictions. After training the MLP, it uses it to make predictions on new data points. The final step is to demonstrate the trained model. In overall, the program aims to build, train, and evaluate a simple MLP model for the given binary classification task. In this experiment, we are using the truth table of XOR gate, where the inputs and outputs are derived from this truth table. Moving to the implementation part, initially we import the necessary libraries such as the NumPy for numerical computations, Pandas for data manipulation, IO represents the input-output operations, and matplotlib for visualizations. Then we define the input and output. X represents the input data and Y represents the corresponding target labels. And these variables define the various dimensions of the neural network. Nx represents the number of input neurons, Ny represents the number of output neurons, Nh represents the number of neurons in the hidden layer, M is the number of training examples, that is the number of columns in X. LR denotes the learning rate for gradient descent, whereas np.random.seed sets the random seed for reproducibility. Then we define or initialize the weights W1 and W2 with random values using numpy's np.random.rand. Losses is an empty list to store the loss values during the training. This function defines the sigmoid activation function, and this function performs forward propagation through the neural network. It calculates the pre-activation and activation values for both the hidden and output layers using the sigmoid activation function, where A1 represents the output of the hidden layer and A2 represents the output of the output layer. This function implements backpropagation to compute the gradients of the loss function with respect to the weights. Its main purpose is to update the weights during the training process. This loop performs training for a specified number of iterations, and we have initialized the number of iterations as 10,000 here. Forward propagation computes the activations. The loss is calculated using the cross entropy loss function. Backpropagation computes gradients. Weights are updated using the gradient descent. This particular code block visualizes the training progress by plotting the loss values over epochs as shown in the screen. The predict function is defined to make predictions on new input data points. It takes the trained weights and input data as arguments. It performs forward propagation to obtain the predicted output label for each input. And finally, using the print function, the input data points are printed along with the predicted output label for each test case. And this is all about the implementation of MLP for non-linearly separable data. Now let us move on to the final part of the video, that is the applications of MLP. MLPs have found applications across a wide range of domains due to their flexibility and effectiveness in learning complex patterns in data. And here are some of the common applications of MLPs. First comes the image classification. MLPs are commonly used for image classification tasks such as recognizing objects in images, detecting various persons' faces, and identifying handwritten digits. They have been employed in various fields including computer vision, medical imaging, and autonomous driving. Then comes the speech recognition. MLPs plays a crucial role in speech recognition systems where they are used to convert spoken language into text. They are employed in virtual assistants, voice control devices, speech to text applications, and voice search engines. They are also used to classify our speech or voice into various emotions such as disgust, anger, fear, calmness, etc. Then comes the recommendation systems. MLPs are used in recommendation systems to personalize recommendations for users based on their past behavior and preferences. They help companies suggest products, movies, music, and content to users, enhancing user experience and engagement. Then medical diagnosis. MLPs are applied in healthcare for medical image analysis, disease diagnosis, patient monitoring, and prognosis prediction. They help analyze the medical images like X-rays, MRI scans for detecting abnormalities and assisting healthcare professionals in diagnosis and treatment planning. And other applications include time series predictions, game playing, anomaly detection, and control systems, etc. etc. So this is the end of the video. I hope you found this video useful. Thank you for listening.